Welcome back to the fourth video of this series. In this video, our main focus will be on storing data in non-volatile memory. This data can be anything, but in this demonstration of a typical Bluetooth Low Energy application, we will be storing the environmental sensor readings in non-volatile memory. This memory can be the internal non-volatile memory of the SoC, whether it's flash or RAM, or an external memory device connected to the SoC via SPI or QSPI. Basically, we'll cover both external and internal memory. So we will create a dedicated thread for storing the environmental sensor readings in non-volatile memory, as you will see in a bit in VS Code. We will call this thread Sensor Data Storage. It will use a subsystem in nRF Connect SDK called NVS. In nRF Connect SDK, you have options when it comes to storing data permanently. You even have various types of file systems available for you for basically different application requirement. We use the NVS that basically allows us to store data on non-volatile memory as ID data pairs. It's suitable for the type of data we have at hand here. And then you will see that in VS Code, I'll first store the data on a partition that is on an external memory connected to the SoC. So the nRF52840 development kit has an 8 megabytes flash memory connected to the SoC via QSPI. That's what I'll do first, and then as you know, not all the development kits has an external memory, so I'll also show you how easy it is to switch the storing partition and use the internal memory of the SoC itself to store these data. Now, how do we move the data from the sensor data collector thread that we defined in video 2 to this new thread, the sensor data storage? We will simply use a message queue that will kind of like handle that part for us. Now, the last thing I will do in this video is getting the stored data via the Bluetooth Low Energy connection. So if you remember in the previous video, we got the current or real-time kind of like sensor readings through these two Nordic status message services. Now in video 4, what we will do, we will get the stored data. So whatever is stored in the non-volatile memory, we will have a dedicated custom service, a custom Bluetooth Low Energy GATT service for it. And you have two characteristics for it. One is called the stored environmental data request, and it supports write operation. So through this, you pass it basically the number of records you want to pull from the non-volatile storage. And then you have the other characteristic, which is the stored environmental data, which supports notify operation. It will basically get you all the data. So enough with the slides, and let's switch to VS Code and get this done. All right, so we're back in VS Code where the action is, and I'm at the last comment from the previous video. So let's go to the Explorer and start modifying the code to include the new functionality. So I'll start with the sensor data collector thread. So it's C file and header file. I will do some changes so that it includes a message queue. So the new thread that I will create, it will be able to receive the sensor data. Okay, so what I'll do first is to define a message queue, and that's very simple, just one line of code you add here. Now it's an empty message queue. We need to populate it with some data through the k message put command. So if we go to the body of the thread, right, and then we go here, we're getting the sensor data, we're printing them, we're sending them over Bluetooth Low Energy connection, the current values to be available, but we also want to make them available in the message queue so the sensor data storage thread that we will create can be able to store them. So I need to put one for the simulated sensor, and I need to put the same line basically here for the actual sensors. Now I also need to define a function that gets me a pointer to this message queue. So I can do it here outside the kind of like thread definition. Since I've done some changes here, I need to put this in the header file. And also, while we are here, since we're going to push this in the message queue, not all of these will be present in the simulated sensor. So for example, you only have these three environmental data for the simulated sensor, while the actual sensor get you also the gas resolution. Same story for the gyro. It's not supported by the simulated sensor. So I need to kind of like change this accordingly. So you can see if you're basically not defining this symbol, include these, otherwise they're not being included, which is the case of the simulated sensor. And this reflects the count of the environmental sensor values that we're providing. So if we're building for the actual sensor, it's going to be 4, so it's going to be temp, pressure, humidity, and gas resolution. If you're building for the simulated sensor, it's going to be just these 3, right? And we're not storing the accelerometer in the sensor data storage thread. All right, then let's create the sensor data storage thread. Okay, so let's create a new file for it. Here, create a new file, and we will call it, I will call it sensor data storage. And of course, I need to update the cmakelist.txt to tell the build system that there's a new file we would like to include in the build. Okay, now the sensor data storage, as we said before, will use the NVS subsystem in the SDK. So intuitively, we need to first enable it in prj.conf, the application configuration file. But since we are basing this application on the LBS sample, the LBS sample actually already uses the NVS kind of like subsystem because it has this feature of security, and it stores the kind of like security the bonding information, the Bluetooth energy bonding on the NVS already. So we don't need to enable it in prj.conf because it's already enabled. And to kind of like further confirm this, if we go to the nRF Connect for Visual Studio Code extension and go to the nRF kconfig GUI, of course, you need to have the build application to see this. If you type NVS, you'll see it enabled already. And if we click here, that's kind of bring us to the points that I mentioned before, that the SDK comes with various type of file systems, and you can kind of like read about them, and we're picking one that meets our requirements for this simple project. But if you have different application requirements, it's also worth checking the other file systems available here. So let's go back to the code and finish. We have just now an empty file. We need to actually create the thread and utilize the NVS system. So I'll do it here, same as we did before. We will create the thread, give it a stack, and give it a function. And then, of course, we need to include the header files of the modules we're using. And also, you'd notice that here I have this environmental storage chunks, and I'm basically storing these sensor readings as ID values pair. So every time I push a new sample to the memory, it has a certain ID. And then if you kind of like shut down the device or reset the device, it always kind of like reads the previous kind of like last ID or record or chunk written, and then add a new one to it. And this is where we're getting the kMessage get. It gets basically a reading from the message queue, which is basically, so this is the kind of like the generator, and this is the receiver of these data. And one key thing that I would like to mention here is the partition. So NVS is so kind of like modular and scalable. You can kind of like make this code work on, like we said before, on the internal memory or an external memory, but you need to define this partition, and this is what we will do in next. Okay, so let's do this memory partition. To do the memory partition, we need to have an idea about the available memory, whether it's internal or external to the SoC and how they're already partitioned. And if we go to this nRF Connect for Visual Studio Code extension and open the device tree visual editor, it will give you some kind of like view of your partitioning for the flash. So we can see that we already have these defined and they're inherited from the device, from the board level device tree files. So if we click on one of them, we can see them and they belong to the internal flash. And we can also see on the, if we go back here to this view, we can see there is an external memory, but it's not kind of like displayed in here yet because there is no partition defined for it. And it's already enabled, by the way. So if we open the SOC and then navigate to the basically the QSPI, you can see it's already enabled. So what I'll do now, I will add a partition for this memory. And keep in mind that I'm doing something called pure device tree partitioning. And in nRF Connect SDK, you also have something called the partition manager that kind of like handles more advanced partition cases. So this is sufficient to do for our sample, to add these lines to have kind of like pure device tree partitioning for our external memory. And I'm giving it this label. You can see now the GUI has updated. See that you have now this 8 megabyte flash. And you can see also that I'm using the same kind of like partition name in my code. And that's how they match. Again, keep in mind that what I'm doing here is called pure device tree partitioning, and there's another way also possible for partitioning using the partition manager. So if I go back to nRF Connect, I guess we're ready now to build the application and give it a try on our development kit. So I'll speed up this part a bit. Okay, so the build is almost complete. Yeah, so let's flash the application to our development kit. What you will notice now is that in addition to the previous functionality we did, we're also storing the environmental sensor readings into the external memory on the board, right? So if I connect now my terminal and then reset the board and observe the output, same as before so far, same thing, but you see this thing. This is an information from the MVS that there is, if you multiply this number by this number, you get 8 megabytes. The same functionality as before. In addition, we're storing the data into the non-volatile memory. You can see latest ID, it means I've been already running this for some time, so there's already 2,557 records already stored. If you run it for the first time, you're probably going to see 0, but then if you leave the device and reset it, you'll see this number keep going up for the already stored record. Next, what I will do is show you how we can change this from external memory to internal memory. And also we will add the Bluetooth Low Energy feature to be able to retrieve all these records from memory. Okay, so I closed all the files and I only have the sensor data storage file opened. And now let's see what are the changes needed to switch from storing to an external memory connected to the SOC via SPI or QSPI to an internal memory on the SOC itself. What are the changes we need to do? The changes actually is just this line. So that's the nice thing about this decoupling in nRF Connect SDK. The partitioning is not supposed to be done in your kind of like C source code. It's done outside, either using pure device tree method or using the partition manager. And all I need to do now is to define a partition internally in the internal non-volatile memory of the SOC itself. So if we go to the device tree here, viewer, we can see these already existing partitioning in the internal non-volatile memory of the SOC itself. Again, 48 kilobyte for the bootloader, for the application 472, and also for the dual slot when you do DFU or FOTA, there is one matching the size, and there is storage. This is again for NVS when used with the internal subsystems like the Bluetooth setting where you store the bonding information and so on. So what I will do, I'll adjust these. Of course, you can use the GUI, or you can kind of like directly type them in the overlay. Again, you're not supposed to modify the board definition. It's better to do it in an overlay because each application will have different kind of like requirement. So what I've done, you can see immediately the GUI have picked up the new numbers. I kind of like shrunk the application size because I know my application is around 400 and I'm not expecting it to grow that big. I'm only going to add little features, so that's something you need to count when you do partitioning. And kept the MCU boot or the bootloader same size. I shrunk down the storage to 20 kilobyte, and then this is my new partition, which is defined in the internal non-volatile memory of the SOC that I'm working with. So all I need to do is just change here from external to internal to match the new partition name. And again, I want to emphasize that I'm doing partitioning using pure device tree. There is another way to do it where you define pm_static.yaml. That's using the partition manager, but I'm not doing it. So just to make sure that people following along here do not build, if they're building for sysbuild, this will not be picked up because it will trigger the partition manager. So I'll add a file. Build.conf, and I need to basically tell it to not trigger the partition manager because I'm not kind of like defining partitioning using the partition manager. That's it. So this step is only kind of like precautionary in case somebody built this with sysbuild. You don't need to do it if you kind of like know you're not building with sysbuild. So that's it. That's all the change that I need to do here to store to the internal flash. So let's actually test it. So let me build. Right, so I'll speed up this part a bit. All right, build is complete, and now we can actually flash to the development kit. And what you should see in the terminal now is that the number of sectors printed is going to be less. We saw back when we flashed the, okay, so it's still flashing, now is complete. And you can see now we have basically 56. So if you multiply this by this, you get 56. And now it's using the internal non-volatile memory instead of the external memory. And it was simply done by changing one line in the code. Now let's move to the next part, which is how do we read these stored records or data chunks on our mobile device? So how do we get them through the Bluetooth Low Energy connection? Okay, so let's get the stored data via the Bluetooth Low Energy connection. So as we mentioned before in the slides, we'll basically create a custom service, custom Bluetooth Low Energy service with two characteristics. One, to request how many records or basically data, kind of like chunks, you want to get through the connection. And the other one will be the notify characteristic that will get you this data. So it's the same as we did in video 3, where we created our own kind of like custom service. So very simple, just add the header files of the modules you want to use, and then define some UUID for the custom service, and then create this service using these nice macros, these powerful macros that can do everything, including the initialization of these service. And we will have this data request function. In this data request, we get how many data is actually being requested, and then we will call the send tail function The send tell function will basically trigger an NVS read history function to get these chunks and then send them through the Bluetooth Low Energy connection. So it's very simple. Just added these lines here and these functions to get me this data and created the service and its characteristics using these macros. So let's build this application and flash it, and then let me also connect my phone. So the build is actually complete, and then we can flash it. And let me connect my phone and open nRF Connect for mobile application to see this new service. Okay, so the flash is complete, and I have mirrored my phone. And if we scan, we can see the sensor node here. And just to remind me to just show you my kind of like hardware setup. It's the same as before. My DK52840, 2 sensors, and my phone. Back to the mirroring. So we can see now the new custom service for getting the stored data here. But let's actually interact with it. So first, again, same as we did in the previous video, in video 3, request the MTU. This is usually done if you have your custom app. It's done kind of like automatically. You can make it automatically through kind of like your API and application development. And here you can see that I've attached a name to the CUID, so that's why it shows stored data. Same as video 3, same as we did in video 3. Now, we have the stored data service open. First, we need to enable notification on the stored environmental data, and then we need to tell it how many records we want to kind of like get. Initially, let me get just the latest one. Send. Okay, so you can see I have record 286, and these are the readings. So this is the environmental readings that we've been capturing. Temperature, pressure, I think humidity, and gas resolution. So these are the records. And now let's request more since we have 200 something. Let's just request, for example, 120 records or data chunks, 120. Send, and you can see they're actually delivered. So these are the records. I'm getting them through notification one by one. So this is how we can test that we actually can read the stored data in the non-volatile memory. Okay, now let's actually switch back to the slides and see what we're doing next. But before that, let me just give you a quick summary of what we did in this video. Okay, a quick summary of what we did in this video. We made 2 kind of like Git commits. The first one was storing the sensor data on non-volatile memory, so you can see the changes. We added a new kind of like file for the new thread. And then we did some partitioning for both an external memory and internal memory. And then we modified the sensor data collector to actually kind of like provide its data through a message queue. That's the header. That's the actual definition, right? And then this is the a new thread, the sensor data storage. And then we also at the end did this kind of like getting the stored data from the sensor data storage thread and make it available via the Bluetooth Low Energy connection. So these comments are good to go back to if you're kind of like following along these videos and you want to start from, let's say, this video or that video. You just point to these comments. Let's see what we will be doing in the next video. So I'll move back to the slides. All right, so we're done with storing the data to non-volatile memory, and we also showed you how to get this stored data via the Bluetooth Low Energy connection. In the next video, we will be focusing on power optimization and how to use the Power Profiler kit and the Power Profile application to power optimize our application. Thank you for watching, and see you in the next video.